In this example, we're going to talk about probability with weights of outcomes. So in probability problems, sometimes we have different weights, like a weighted coin or a weighted die. We have different type of examples like this, and we need to learn how to work problems like this. So first, let's look at the definition. Each outcome of an experiment can be given a weight. This weight would be that probability, which is a positive number between 0 and 1. So there wouldn't be any negative weights. That wouldn't work for us, and there wouldn't be any weights that would be greater than 1. And if you add up all of the weights together, if you add them all together, then they have to equal 1. Okay? But let's look at an example and make sure that that makes sense. So here's an example. A 6-sided die is weighted so that all even numbers have an equal chance. All odd numbers have an equal chance. Each odd number is 4 times as likely as each even number. And the question we're trying to get is, what is the probability of rolling a number 1? So with this weighted coin, what is the probability of rolling a 1? Okay. So this isn't a normal die where all of the numbers are just 1/6 chance. This is weighted so that the evens equal each other and the odds equal each other. So even 1 equals even 2 equals even 3, and odd 1 equals odd 2 equals odd 3. Okay? And I also know that if you add all of these together, if you add all of these together, then they have to equal 1. Right? There's a 100% chance that something will happen. Okay, so if you take all of these weights, add them together, it has to equal 100%. If you roll a die, something's going to get rolled. Okay, so how can we do this? Well, we have 3 evens, they're all equal. We have 3 odds, they're all equal. So I'm going to rewrite that green equation as 3 evens plus 3 odds equals 1. All right? That would be the first equation I can make to solve this. Another way I can continue is that each odd number is 4 times as likely as each even. So each odd is 4 times as likely as even. So it takes 4 evens to make 1 odd. And with these 2 equations and 2 unknowns, I can solve the entire problem. I can solve for every number. They want specifically what is the probability of a 1, but I can solve for all of them. Okay, so what can we do from here? Well, we can plug this information that 4 evens make an odd into the first equation. So that's what I'm going to do. I'm going to plug this information into here, and then I'll be able to solve. Okay, so this would be 3 evens plus 3 times 4 evens equals 1. Right, so I have odd equals 4 times even. I plug that information in for the odd, and then I rewrote the first equation, and there's my 4 even for odd. Now I can just use simple elementary algebra to solve the rest. So 3 even, 3 times 4 is 12, even equals 1. And then 3 and 12 make 15, even equals 1. And so even equals 1/15. Okay? So there's the even. So an even number, even 1, 2, and 3, individually equal 1/15. So we know what the even numbers are. But what are the odd numbers? What are the odd numbers? Well, it's 4 times even, and 4 times 1/15 would be 4/15. Okay, so I think each odd number would equal 4/15. So I think the probability of rolling a number 1 when rolled one time is 4/15. Okay. All right. So hopefully that helps of how you can do a problem like this. We can actually answer any problem we might need, and I'm going to make a second part to this video, but that should get you started. Okay, hopefully that helps.